Today's lecture is going to go over flow rate, time, and calculating the variations. So as you see here on the screen, the first example we got here is a hospital policy permits recalculations of IVs when off schedule with a maximum variation of 25% for patients who are stable. Okay, so we got this information. We see that we have an order here. It says 875 milliliters for 6 hours, and we're going to have a flow rate of 150 milliliters per hour. And then we have this drop factor of 20 drops per milliliter. So the first question is, we want to know the original flow rate in drops per minute. So what I'm going to do is take the given flow rate. It's not always given to us. So let's just make a little side note before we go further. If for some reason this was not given to us, then we would take our 875 milliliters and divide it by the 6 hours, the time, because it's volume over time. And then we would get our 150 milliliters per hour. So if you weren't given that, that's how you can figure it out. In this case, though, we were given it. So let's take that 150 milliliters per hour and let's multiply it by the drop factor. Now remember, the drop factor does not change. It's the tube that's connected to our patient. Let's reduce our milliliters. And it said per minute, drops per minute. So what I'm going to do is replace the H with 60 minutes because we know 1 hour is 60 minutes. So watch that. This does have 1 hour in front of it, so that's all we multiply by. So let's do this. You can multiply straight across and reduce, or we can go ahead and reduce right now. I know 20 goes in itself once, goes into 60 3 times. So now I have 150 divided by 3, and this gives me drops per minute. I'm going to use approximation sign. So 150 divided by 3 is 50. All that works out nice and pretty. I was double checking myself. I was thinking it would. All right. Remember, if you get a decimal, you cannot get a partial drop, right? So you have to correct that. So let's do the next question. The next one says, after 3 hours, you notice that 600 milliliters are remaining. So he wants to know what's the remaining time. Well, the starting time was 6 hours. You've got 3 hours later. So it's a total of 3 hours. That works out great. So the remaining time is 3 hours. So now we're going to recalculate the flow rate. So we're going to take our remaining volume and divide it by the 3 hours that's left. So our remaining volume divided by the remaining time. And we're going to divide that. And that's what going to give me 200 milliliters per hour. Because all I did was just reduce. 3 goes in 6 2 times and leaves me with those zeros. Okay, so now I got 200 milliliters per hour. Let's recalculate the flow rate in drops per minute. So I'm going to take that 200 milliliters, and in the place of that H, I'm going to put 60 minutes. I'm going to multiply that by my drop factor because remember, it didn't change. It's still connected to my patient. Oops, it's milliliters. So I'm going to reduce my milliliters. Now I can do this. 20 goes itself once, goes in 63 times. And now I have 200 divided by 3 gives me, now this is going to give me a decimal place. It's going to be approximately 66.7 if I round. However, remember, or hang on, let's not round. Let's just put what we know. We got 6, and I'm going to put a bar above it, meaning repeated milliliters per hour, excuse me, per minute. We cannot take a partial drop. So this here tells me what's going to happen to the number in front of the decimal. Since it's bigger than 5, we know we're going to add 1. So now we get a total of 67 milliliters per drop. Oh, and that is a typo. Guys, it's not milliliters per drop. I hope y'all caught that. I said it all wrong. It's drops per minute. Whoa. So I hope you caught that. Okay, so now let's move on. Let me raise the screen up. Let's talk about variations. So in most of the textbooks, you're going to see it talks about a variation of 25%. So let's draw this variation now. 0 is a good, and I'm going to dig a little deeper into this as we get to that. But 0% is good. And what do I mean? I am talking about a comparison between the original and the recalculated. Okay. So we want to know something went wrong during the process and they had to start over the calculations because they have a different remaining time, volume, who knows what happened. So we're going to have to do some work here. We want to know that the recalculated is correct and it's what we need it to be. So that's what this variation protocol comes in. So I know 0 to positive 25%. We're going to say it's good. However, it means it's running a little slow. Once you get past that 25%, it's too slow. So I'm going to say that my adjust is too slow once I pass the 25%, the positive 25%. But in between 0 and 25, we're going to say good. 0 is perfect. Now 0 to negative 25%, we're still going to call it good. However, if we go beyond that negative 25%, like we get negative 19%, we're going to say it's too fast. Okay, so the adjust is too fast. As long as we stay within that 25%, that's all good. Now the 0 is perfect. All right, so now I'm going to erase this. So if you want to write this down, I'm going to erase it so I can do the next part. All right. Now, what we're going to do is we're going to take our adjusted minus our original divided by our original times 100%. This is going to give me my variation, my percent variation. So my adjusted was 67 drops per minute. And then my original, if we go back up there to the top, my original was 50 drops per minute. See, it's highlighting blue. So minus that 50 drops per minute, all divided by that 50 drops per minute. And then when I'm done with that, I'll multiply by 100%. Now, we cannot add or subtract if they're not common or like terms. And we got drops per minute minus drops per minute. They are alike. And then we divide it by this. The units actually reduce out because when we subtract these two, so I got 67 minus that 50 gives me 17, right? So I got 17 drops per minute, all divided by that 50 drops per minute. Remember we do a keep change flip. So this here flips and they reduce, the units reduce, and now we don't need them anymore. It's just basic math. So they become 1, so I'm left with 17 over 50 times that 100%. So 17 divided by 50, and then let's times it by 100, which is 34%. I'm going to say this is too slow. It is beyond the 25%. It's on the outskirts of the positive 25%. It's over here somewhere, right? So that means this here is too slow. The adjusted flow rate is too slow.